Homework for Wednesday, April 18th. Number 1. Mabel made Easter eggs filled with jelly beans. She used 32 green jelly beans, 48 yellow jelly beans, and 64 purple jelly beans. She used the same number of each color in every egg. What is the maximum number of Easter eggs she could make? So, the answer I got is 16. How did I get 16? Yes? Greatest common factor. And to do greatest common factor, we need to do a factor tree. A factor tree. So, I'm going to start with 64. It's the largest number. And then maybe once I look at the prime factorization for that, the rest will make sense. Okay, 2 factors of 64. Anyone? Doesn't matter. Any 2 factors of 64. 16 and 16 times 8. 8 times 8, right? 8 times 8 is 64. Those are those prime or are those composite? Composite. So 2 factors of 8 are 2 times 4. 2 is prime. 4 is composite, so 2 factors of 4. 2 times 2. Do that same thing over here for this 8. The prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2. If I multiply all those 2's together, they're all prime numbers, I'm going to get 64. The next number is 32. 2 factors of 32. Yes? 4 times 8. 4 times 8. 4 is composite, so 2 factors are 2 times 2. And we've already done the prime factorization of 8 over here. 2 times 4 and 2 times 2. So the prime factorization of 32 is 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. So that's 32, and then 32 times that 2 would be 64. So I see how those all relate. The last number is 16. No, oh, 48. I'm sorry. 48. 2 factors of 48. Yes. 8 and 6. 2 factors of 8 are 2 times 4, 2 times 2, and 2 factors of 6 are 2 times 3, and those are both prime. So now list prime factorization in order from least to greatest. 2 times 2 times 2 times 2 times 3. Now what's the next step? Find the common multiples. So they all have this 2, so list it one time. They all have this 2. They all have this 2. And they all have this 2. Can I use these 2? No, because it doesn't have a match. This is the only 2 here. None of them have a 3. So 2 times 2 is 4. 4 times 2 times 2. 4 times 2 is 8. And 8 times 2 is 16. So we can make 16 Easter eggs filled with jelly beans. Now, does that mean there's going to be the same number of green, yellow, and purple in each one? No, there's only going to be 2 green jelly beans. If I make 16 Easter eggs, there's only going to be 2 green jelly beans. And is that 3 yellow and 16 divided by 4. So 1, 2, 3. So what is that? 4 of those purple jelly beans in each one? Or 3? So it doesn't mean that there's going to be the same number of each of those jelly beans. It means there's going to be an equal amount in 16 jelly beans. Does that make sense? I struggle with making sense of that in the beginning. Like, how am I going to put 16 of each color in the jelly beans? But that's not what that means. Do you understand what I'm saying? Yes? Okay. Any questions on number 1? Number 2, this says, what is the negative of the absolute value of 18? So, negative means opposite. So, what's the opposite of the absolute value of 18? Well, what's the absolute value of 18? 18, because absolute value is always positive. Absolute value is the distance from 0. So, if it's negative 18, it's still 18 hops from 0. If it's positive 18, it's 18 hops from 0. Distance is always positive. So, absolute value is always positive. So, this is saying what's the opposite of the absolute value of 18? Well, the absolute value of 18 is 18, and I just bring that negative down. So, your answer is negative 18. Does that make sense? Yes? Okay. All right. So, this is saying the absolute value of 20 minus the absolute value of 7. So first I have to get rid of the absolute value bars. Well, the absolute value of 20 is 20. And the absolute value of 7 is, or of negative 7 is 7. So if I subtract 20 minus 7, you get positive 13. So your answer is 13. So the first step is get rid of the absolute value bars. That's a positive, and then 20 minus 7 is 13. What point is a reflection of the point negative 2, negative 5 across the x-axis? So let's think about what we know about the coordinate plane. All right, so you should be able to do this on your notes page when you take Georgia Milestones, right there. This, what coordinate is it, or what quadrant is this? What quadrant number? Well, that's 1. What's this one? 3 and 4. Okay, so what axis is this? X. What axis is this one? Y. I need to know that. These points right here are positive, positive. My X, I go in the positive. My Y, I go in the positive. What is this one? So your X is first. So if this is 0 and I go that way on the number line, I'm going negative. And then if I go up, it is positive. This quadrant, negative, negative. If I go here on the number line, that way is negative. On the Y, negative. And this quadrant is positive, negative. So I need to know that. So the question says, what point is a reflection of the point negative 2, negative 5? So negative 2, negative 5 is over here. It's over here somewhere. So if I reflect that across the x-axis, that means if this is the x-axis, I'm going to jump from here straight over to here. So I'm going to be in this quadrant. So now I am a negative positive. Instead of a negative negative, I'm a negative positive. So I'm going to take that. The x still stays a negative, but my y goes from a negative 5 up to a positive 5. So what point is the reflection of negative 2, negative 5? So if I jump across this axis, that negative 5 is now a positive 5. Everybody get that one okay? I noticed what yesterday afternoon some people were struggling with reflections. If I'm going this way to this way, I'm reflecting across what axis? I'm reflecting across the y. So if I jump across the y, it changes the x. If I jump across the x, it changes the y. Does that make sense? So if it tells you that you're jumping across the x, it's your y value that changes. If you jump across the y, it's your x value that changes. Yes? It's difficult 3 days before state testing to see a sea of blank faces out there. I don't know if you know that. Like, we've worked all year long, and then I'm talking, and it's like, it's a difficult thing. It's kind of nerve-wracking. Not sure if you know. Okay. All right. Order from least to greatest. No, I'm sorry, greatest to least. So the biggest number, your larger numbers are positive. Your smaller numbers are here. So 80, 19, 16, 15, 12, negative 9, negative 14, negative 15, negative 90, and the smallest of all those numbers is negative 111. The further you go left on the number line, the smaller the numbers get, right? So negative 9 is bigger than negative 13. Everybody's okay with that? Okay. All right. Compare negative 2/3 is less than negative 6/10. So you need to change that to a decimal. So how do I change negative 2/3 to a decimal? What's the math to change your fraction to a decimal? Hayden? Okay, so the numerator divided by the denominator, 2 divided by 3, and you get negative 6 repeating. Well, to me, do those numbers not look equal? So can I tell by looking at the tenths place if they're equal or not? So what's the next number if I were to continue this one? A 6. What's the next number if I continue that one? A 0. Now, if these were positives, 66 would be bigger than 60. But since they're negatives, this one is smaller than that one. Correct? Everybody agree with that sign? Yes. Okay. What is the distance between the 2 points, negative 9, negative 3, and negative 9, negative 12? So, negative 9 and negative 3. And negative 9 and negative 12. All right, so is there any distance between the x's? Negative 9 and negative 9, any distance there? No, it's the same number, so I'm not talking about that. I'm talking about these two. So, on a number line, how far apart are they? My number line wasn't long enough. How far apart are they? So if I were to count from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9. The distance between them is 9. They're negatives. Is it going to be negative 9? Distance is always positive. So your answer is the distance between the two of them is 9 units or 9 places. Does that make sense? Because they're negatives, don't choose a negative 9. Distance is always positive. All right, connect the points. Let me erase so we can start over here. Connect the points C, H, I, and B, and then find the area of that trapezoid. So, C to H is here. H to I is here. I to B is here. And then close it right here. All right. So I could have done that like a trapezoid, or I could treat it like a composite figure. So I'm going to cut it right there. So what two shapes do I have now? Right there. What do I have? A triangle and a rectangle. Let's find the area of the rectangle. 2 times 3. 6. 1, 2, 3, 4, 5, 6. I agree. That is 6. All right. What's the formula for area of a triangle? 1/2 base times height. Here's where my right angle is. So my base is 1, 2. So 1/2 of 2 times, and my height is 1, 2, 3. 1/2 of 2 times 3. 2 times 3 is 6, and half of 6 is 3. So the area of the triangle is 3, and 3 plus 6 is 9. 9 units squared. All right, questions? That's it? Okay, let's look at our milestones practice. That's the 7th grade. We don't need the 7th grade review. Not yet. All right, so we're on statistics, is that correct? Unit 6 statistics. All right, John questioned the first 22 students to arrive at school. What type of sampling technique does this represent? Well, observational just means you're watching, so that's not questioning. Representative means that's a representative of the entire population, and I don't know that that's true. The first 22 people that got off the bus could be all 6th graders. And so that doesn't represent the opinions of 7th graders and 8th graders as well, so not representative. It's not random. If I'm asking the first 22 people, that's not random. So the only thing it could be is biased. Biased is bad, and that's not how you want to take a survey. So C. 2. Which test has the most variation? My answer is B. Why would B have the most variation? What does variation mean? Have you ever heard the term answers may vary? Lots of differences. So here the data is more spread out. The minimum and maximum are further apart. The interquartile range right there is further apart. So B has more variation. The data is more spread out than the data in A. Not as much variation. These are more alike. These data points are more different. 3, what is the interquartile range of A? Interquartile range means the range of the box. Quartile 1 and quartile 3. 40 minus 15. Or I could just count by 5s on this one. 5, 10, 15, 20, 25. Interquartile range is 25. So I could say 40 minus 15. You get 25, or I could have just counted by 5s. What is the median of A? The median is the middle line in the box, and so that is 30. The median is 30. What is the range of B? How is range different than interquartile range? Those are two different things, right? Interquartile range is the range of the box. The range is the highest minus the lowest. How far apart are the highest and the lowest is the range. So 50 minus 0, so the range is 50. Questions on the difference between interquartile range and range? No? Okay. What is not true regarding a bar graph and a histogram? A bar graph bar graphs are usually used to display categorical data. Is that true of a bar graph, or is that specifically a histogram? That's a histogram. So A is not true about a bar graph. Okay, let's look and see. Histograms are usually used to present continuous data. That is true. The way the graphs are drawn, histograms are never drawn with spaces between the bars. Is that true? Yes, never spaces between the bars. It is more appropriate to talk about the skewedness of a bar graph than a histogram. Well, we can discuss them both of them being skewed, right? What does skewed mean? Like there's a lot more data on one side than the other. You can talk about that with a bar graph and a histogram. So the only one is A. Questions about a bar graph and a histogram? No. Okay. A school is interested in expanding its library. A school interested in expanding its library counted the number of items that students checked out books in a term. The number of times that students checked out a book in a term. So, each one of these, so what do each of these X's represent? Are they books? Yes. So right here, this is the number of times that a student checked out a book. So this means that 1, 2, 3, 4, 5 students checked out a book 0 times. So each one of these is a student, and it represents the number of times they checked out a book. Okay? How many students checked out a book 1 time? 0. Okay? 2 of them checked out a book 2 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 students checked out a book 3 times. You understand how to read a line graph? Yes. How many students checked out a book more than 3 times? Does that count 3 times if we're saying more than 3? No, so it's not this one. Does it count 2? Is 2 more than 3? And 1? 0? So we're only going to count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 students checked out a book more than 3 times. What is the sample size? Sample size means how many people were in the entire survey. So the sample size is 37. I had to count all of these X's to get 37. Rounded to the nearest tenth, what was the mean number of times books were checked out during the term? So how do I find the mean? I had to add them all up. So 0 plus 0, that's all zeros. 2, 4, 6. 9 times 3 is 27. 4 times 4 is 16. 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 5 is 50. 4, 5, 6. 6 times 6 is 36. Add them all up. 2, 4, 6. So this is 2 times 3 equals 6. So 6 plus 27 plus 16 plus 50 plus 36 is 135 times a book was checked out. What am I going to divide by? Maddox? Huh? Well, how many X's are there? We already figured that out. How many X's are there? 37. We have to divide by 37. Books were checked out 3.6486, and we have to round to the nearest tenth. That 4 tells that 6 to stay a 6. So your answer is C, 3.6. Everybody know how I did that? Yes? So I could have just sat here and said 2 plus 2 plus 2 plus 3, 3, 3, 3, 9 times, right? But I did some math, so that way I didn't have to do as much calculator work. All right. Last one. Last year, the school made $800 at its cookie sale. This year, it made $1,200. Suppose you show these amounts on a bar graph, but you start the vertical scale at 600 instead of 0. Exactly how many times taller will the second bar be than the first? How might this be misleading? So, I've got to draw a bar graph. So, and normally, you would start right here at 0, but they're saying they're going to start it at 600. And I'm going to go up by hundreds. That's my scale. And then I'm going to choose last year and this year. So, last year, they made $800, so we just went right here. This year, they made $1,200. How many times bigger is that? Well, this one was 200. So, if I go here is 200. Here's another 200. How many times bigger is this one than this one? I should be able to see it in my picture. 1, 2, 3 times bigger. So is that an accurate reflection of what happened when it went from 800 to 1,200? Did it get 3 times bigger? Is that an accurate reflection, this graph? Is that a good graph? Did this amount really get 3 times bigger? Well, if I multiply 800 times 3, am I going to get 1,200? 800 times 3 is 2,400. So, did we really sell 3 times more? We didn't. Why does this graph appear that it's 3 times as much? Well, because we didn't start down here at 0. We cut off this whole 0 to 600 part of it. So that's why your scale is important when you're graphing. You have to start at 0 to show the accurate amount for the first year. This does show the second year. But it cuts off down here. They're all exactly the same from the 0 to 600. Does that make sense? And do you all see how I see that this is 3 times bigger? Yes? No? Maybe? Not sure what you're talking about. What's a graph? What's a bar graph? What does times mean? Are we all there together? Okay. All right, let's look at the back. The back, Unit 6. This was actually our Unit 7, but we learned it at the beginning of the year after Unit 1. We get to skip number 1. This is going to be what we learn after milestones. This is the beginning of 7th grade. But it says find the difference, 1 minus negative 10, or 1, and then we would move the opposite and the opposite. You did not have to know how to do this, but let's think about it. If I'm on a number line, and I am at 1, this minus tells me to turn and go this way, but then this minus means to turn around and go that way 10 places. So if I'm at 1 and I move 10 places in the positive direction, where would I be? We would be at 11. Lots of people got that answer to be negative 9, but that's not what that is. Minus a negative is the same thing as a positive. A double negative is the same thing as a positive. So what we're going to learn next year is that becomes 1 plus 10 equals 11. All right. 2, order the integers from greatest to least. So the biggest number is 8, 4, 0. Then -3 and -5 is the smallest of all of them. If I was about to get money, if I was about to get $10, would I have more money left at the end if I paid somebody $3 or if I paid them $5? I would still have, if I got $10 and I paid somebody -3, I'd have $7. But if I was getting $10 and I paid somebody $5, I'd have $5. So this number is smaller than this number. Does that make sense? Anytime you move this way on the number line, you're getting smaller. Anytime you move this way on a number line, you're getting bigger. Find the absolute value of -4. Well, absolute value is always positive, so your answer is D. 7. At 4. At 7 a.m. the temperature was -2. In the afternoon, the temperature was 11 degrees Celsius. What was the change of temperature during the day? So I said to draw a number line to help. You use a vertical number line, that means straight up and down, for temperature. So if we're at 0, you always want to have your 0 mark there. So if we start the day at -2, and we're going to end the day at 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What was the change? So if I'm going from here to here, how many places is it? Well, to go from -2 to 0, I had to go up 2 degrees. And then from 0 to 11, I went up another 11 degrees. So altogether, we increased how many degrees? 2 plus 11 is 13, or I could have just done hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 degrees Celsius was the change in temperature. And change is distance on a number line, and that's always positive. What inequality does this number line show? Well, this is telling me that my variable is going to represent any number bigger than C, or bigger than 2, or equal to 2. So the C is the answer. C is the answer. X is any number that is greater than or equal to 2. Which point is in quadrant 4? So I drew my quadrants quickly, and that one is 4, and I know that that is a positive and a negative. Positive and negative is A. Which sign makes this statement true? -1 1/5 is greater than -3 2/5 on a number line. If I were to try and place them, -1 1/5 is between -1 and -2, but it's closer over here to -1. -3 2/5 is between -3 and -4, and it's closer to halfway between the two. And anytime I go that way on the number line, the numbers are getting smaller. So this one is larger than this one. It goes that way. Or I could think about if those were positives, this one would be bigger. And so since they're negative, the opposite is true. Which set of coordinates represents the rectangle EFGH after a reflection over the x-axis? So if I took this and I just flipped it that way, this point's going to stay here and this point's going to stay here. This point is 1 up, so this one's going to be 1 down. And that one is going to flip and it'll be right there. So these 2 points stay the same. So that's -1 and 0, -1 and 0, and let's see. And negative, that's -2, 0. That would be there. -1, -1, -3, -3. Or is one of these not right? Is this one not listed correctly anywhere? I feel like they just have a misprint there. I think that should be a -1, 0. A -1, 0, and a -3, 0. And then this point is -1, -1, and this one is -3, -1. So it's B, but this should be a -1 and not a -2. Otherwise, there's none that are correct. That one's a misprint. I need to check that. All right, so you all know how we need to flip it from here to go down there because we were jumping over the x-axis. We were reflecting over the x. What is the horizontal distance between the coordinates -1, 0, -3, 0? So if I'm thinking about -1 is here and -3 is here, we're talking about these two spaces. What's the horizontal distance between the two? 1, 2 places. So your answer is A. And even though we're on the negative side, distance is still always positive. All right, the last question. A building has 4 floors of offices above ground and 5 floors of storage below ground. A worker goes up to the 3rd floor to get some file folders and takes them down to a storage room on the 4th underground level to have files stored. How might a number line help you solve this problem? So how does a number line help you solve this problem? Yes. Yes. I said I can see distances. It helps me see distances. It helps you picture where things are. Something like that. Should 0 be on your number line? And explain. And I said, yes, it is the ground floor. So on my number line, it's my ground floor. So yes, it's the ground floor. C, sketch a number line. Graph each integer for the 3rd floor, storage room, and main lobby. So, the ground floor is 0. There's 4 floors of offices above. 1, 2, 3, 4, and I call those offices. There was 5 floors of storage underneath, so I go to -5 for storage. And so she went up to the 3rd floor, so I put a point there. She went down to the 4th underground level, that's there. And the main lobby, I had to read Part D to find out where the main lobby was. Part D says how many floors does she have to go to get back to the main lobby on the 1st floor. So the main lobby is on the 1st floor. And it says how far does she have to go to get back. So she went this way, and then she went down, so she was here. Now how many floors does she have to go to from here to get back to the main lobby? Well, it's 1, 2, 3, 4, 5. 5 floors to get back to the main lobby on the 1st floor. So you should have had answers that looked something like that. Make sure that when you work on constructed responses, if there's a part A, B, C, or D, that you label those in your typing. So you can clearly see my answers to part A, part B, part C, and part D. correct? Yes. Okay, any questions? No. Okay, you can hold on to that to look over it if you like. Has everybody with your homeroom looked at the practice milestones test? You've logged in. You've looked at the practice test. Did everyone find the formula sheet for math? You all were able to find the 6th grade formula sheet. You'll know how to use that. Michaela, did you see it yet? Yes. Aiden, did you see the 6th grade math formula sheet? And when on the milestones practice test, did you go look for the formula sheet? Yes. Yes. Andrew, do you know where it is? You weren't here yesterday. Okay, so we need to look at that. All right. Any questions about anything? You've got about 8 minutes to keep working on corrections or IXL.